Good afternoon, scientists. Welcome to MOS at Home and our Science in Action presentation. Today's topic is super cold science, where we're going to find out what happens when temperatures go extreme. My name is Sue. My pronouns are she and her. I'm your moderator today, which means you'll be sharing your observations and your questions with me via the Q&A function in Zoom icon at the bottom of your screen. I'll share what I can with our guest educator, Emily. Remember to share your first name and your age if you'd like a shout out. Also at the bottom of the screen, you will notice there's a closed caption icon if you would like text subtitles. We're excited to have so many of you joining us via YouTube and Facebook, but just need to be aware that you will not be able to participate in the Q&A in either Facebook or YouTube. Now, with all of our instructions out of the way, I think it's now time for Super Cold Science. Take it away, Emily.
Hi everyone, and welcome to MOS Live. Just as Sue said, my name is Emily, my pronouns are she and her, and today I'll be showing you just what happens to the objects around us when we change their temperature. Now, I will be using liquid nitrogen today, and you'll eventually see that liquid nitrogen inside of this glass container on this side of my table. I'll also be doing a whole bunch of experiments with that liquid nitrogen using the rest of the equipment on my table. And then finally, at the end of the program, we're going to attempt to make a really big mess with this bucket of water on this end of my table. So until we get to all of those experiments, the very first thing that I want to do is go over the basic science behind all of these experiments, because I want to give you the tools to be able to predict what will happen in these experiments even before I do them. So basically, this is what it comes down to. When you make objects hotter, they grow or expand. And when you make objects colder, they shrink or contract. Now this happens because everything around us is made out of molecules, which are little teeny tiny pieces that are so small we cannot see them. But these molecules are inside of everything. So they're inside of the air that we're breathing, they're inside of the water that you drink every day, and they're even inside of the solid objects around us. Now, when we change the temperature of these things, the speed of those molecules actually changes. And keep in mind that those molecules are always moving, but their speed depends on the temperature. So for example, let's say you have a pair of molecules moving in front of you. If you were to make this object, whatever these molecules are inside of, if you were to make this object hotter, these molecules would move faster and also get farther apart. And then if you were to make them colder, they would move more slowly and get closer together. So that's what makes the things around us grow and shrink with a change in temperature. It's all because we're changing the speed of those molecules. So let's start to see this in action, and let's also start to see the star of this program finally emerge. I'm going to bring out the liquid nitrogen, which is a really fascinating substance. I'm going to pour it into this glass container, like I promised, and all I want you guys to do is watch it, check it out, and start making some observations, and put those observations into the Q&A box, just like what Sue said at the beginning of the program. That is the best way to interact with us, with that Q&A box. So here we go. All right, it's looking pretty good. I'm going to put just a little more in there.
No observations yet, but remember, I'm sure there's a lot of things everyone's noticing, so feel free to share them. Sophie says it looks like clear water. She's age 11.
Ooh, yes, that's a really good observation. It does just look like clear water that is, doing something in front of us.
Kip, age 7, is saying the liquid is hot, but it's producing gas.
Okay.
Megan, who's 8, says there's white air coming out of the top. I forgot the name, but it's like steam. Dahlia and Luna see bubbling. They're ages 6 and 9. I'm seeing gas. Kristen says it's very cold and steaming. Lydia, who's 5, said it looked like it was flowing out and vapor was going down.
Yeah, these are all really amazing observations. I am curious to know if there are any liquid nitrogen nerds out there. Can you tell us what the actual temperature of liquid nitrogen is? It's kind of a quiz for you all. If you happen to know, tell Sue if you know.
Right. I'll hold for a moment.
I will start talking about those observations a little bit, though, because we were seeing bubbles kind of erupting from this liquid. We can still see smaller bubbles, especially when we zoom in a little bit. We also saw a ton of what almost looked like smoke coming out of this container. And a better word for that smoke would be a fog, and that's because it was falling down. So any known temperatures yet?
We had a minus 22. We also had minus 170 degrees Celsius from Pranav.
Yeah, very good. So a lot of you already know that liquid nitrogen is an extremely low temperature liquid. And the actual temperature of this stuff is negative 321 degrees. Now, liquid nitrogen is colder than the coldest recorded temperature on this planet. And that actually happened in Antarctica, and that temperature was negative 126 degrees Fahrenheit. So that means that this liquid right here on my table is 200 degrees colder than the coldest place on this planet, which is just incredible to think about. And that's why we can use it to very quickly change the temperature of the experiments that I brought with me. So this stuff is boiling. Okay, that's why we see the bubbles kind of erupting inside of it. That's why we see the fog coming out of it as well. I'll even add a little bit more nitrogen so that we can see this even better. Very good. You can see more of that fog coming up. And something that I didn't tell you before is that if you change the temperature of an object enough, you can actually change its state. So for example, if you raise the temperature of a solid to a high enough temperature, it will melt and turn into a liquid. And then if you raise the temperature of a liquid to a high enough temperature, it will boil and turn into a gas. So what we're seeing is our liquid nitrogen boiling and bubbling and turning into a gas. And keep in mind that we can't technically see gases, but we can see evidence that a gas is being created because we're seeing that fog, which is little tiny water droplets that are condensing in the gas that's being created. All right, very good. So I hope that I hit on all of the observations that were made in that Q&A box. So what I would love to do is actually start experimenting with this liquid nitrogen. And the very first thing that I want to show you is this can that is sitting front and center on my table. Now what I'm going to do is pretty simple. I'm going to take some liquid nitrogen and I'm going to pour it into this can. And then I'm going to take the cover of this can and seal it on top. And I want to know, what do you think will happen when I do that? Now, try to remember the science that I told you at the beginning of the program. Keep in mind that when things get hotter, they expand. And when things get colder, they contract. And remember that liquid nitrogen is a cold liquid. But also remember that it's boiling, which means something has to be heating it up. So what do you think will happen when I put it into a sealed can?
Well, we have Abigail, who's already guessing that the cap will fly off, and Kay, who thinks the can's going to burst, Madeline, who thinks the lid will pop off, Jay, who thinks it will explode or implode, perhaps.
Oh, wow, that's a cool one too.
Dahlia, explode.
Okay.
And the lid's coming off. I think we're on the right track here, everybody.
Yeah, it sounds like everyone's on the same page for sure. You're all thinking that it's either going to make the lid fly off the top, or maybe the whole can will explode. Hopefully not, because this is made out of metal, and I'm gonna be pretty close to it, but we'll see what happens. You just never know. All right, so here go my goggles. We'll get a scoop of this stuff, pour it into the can, let it boil for a few seconds, and let's see what happens. 3, 2, 1. Woo! Wow, oh my gosh. Okay, that was interesting. So let's try that again. We'll go back to that close-up shot of it, but I actually just want to back up a little bit. Actually, you probably could have just stayed on that wide shot. Sorry about that. So let's back up a little bit, just so we can see an even bigger view of what just happened. So here we go in 3, 2, 1. Woo! Wow, that was incredible. So what we're seeing is that the cover of this can keeps popping off the top. And that is happening because our liquid is boiling, which means that something is heating up that liquid. It's making those molecules move faster and get farther apart, which means that the gas that is being created is taking up more space than the liquid. And it turns out that this little tiny can is not actually big enough to hold all of that gas inside of it. Now, I do want to do this experiment one more time. Let's go retrieve that little cover. And for this last time that we'll do this experiment, we're actually going to zoom in even closer on this can. So let's go ahead and find the right preset. There we go. And I want you all to watch really carefully to the lid, because you can actually see it bubbling up as the gas inside of it is pushing on it. So here we go, one last time. 3, 2, 1. Ooh, amazing. Awesome, awesome job. Those were such good predictions because you all basically knew what would happen even before it happened. So amazing job. All right, so Sue, I'm curious to know, are there any questions that are coming into the Q&A box? And if there aren't, then we can go on to the next experiment.
We got one a little earlier from Pranav, who wanted to know if you could solidify liquid nitrogen in the lab.
Yes, absolutely. It does have to happen in a lab, just like how liquid nitrogen is made in a lab or in a factory as well, because this stuff is basically too cold for our planet. It cannot naturally exist. But yeah, if you lower the temperature of liquid nitrogen, I think just by, I can't remember the exact temperature, but maybe by 20 or 40 degrees Fahrenheit, then it will solidify and become solid nitrogen. Really good question. Yeah. Any others, or should we move on?
I think that's it for questions.
Awesome.
We can move along.
Okay. So the next thing that I would like to do is start putting something into the liquid nitrogen to see what happens to it. So I'll start by using this balloon. Now, this balloon is something that I blew up myself, so there's regular air inside of it. There's nothing really fancy about these balloons, but what I will do is put them inside of the liquid nitrogen. And I want to know, what do you think will happen to the balloon? Or what do you think will happen to the gas inside of it? So start putting your guesses into the chat box, and I'll start to bring out the other balloons that I brought with me, because I'm basically going to attempt to fit as many of these balloons into that container as I possibly can. And we'll have to see if it's actually possible. Ooh. So what will happen to those balloons?
Let's see, we've got some shrink, we've got some pop, We've got collapsing,
Ooh, okay.
exploding.
You guys just want an explosion to happen, I can tell. So those are all kind of different predictions. Maybe they'll shrink. Maybe they'll collapse. Maybe they will explode. Maybe they'll break. So we're kind of across the board on this one. Let's just go ahead and find out what happens. So we'll zoom in on this container. Everyone watch carefully and maybe listen closely as well to see if my microphone actually picks up on any interesting sounds that are coming from this container. So let's do our good old pink balloon first. In 3, 2, 1. Okay, it's kind of interesting. Let's put a few more in there. Again, we'll kind of see how many we can fit. Oh. I wonder if any of you had a guess as to how many of these balloons would fit in this container. And I'm wondering if I've already put more than you thought. All right, this is the last balloon that I blew up today, unfortunately. But I did successfully fit every single one of them into that liquid nitrogen. So now I'll start to bring them out. I'll put them right here on the front of my table, and we can actually see what they've been doing inside of there. So here we go. 3, 2, 1. So it almost looks like a shriveled up balloon pancake when it first comes out of the liquid nitrogen. Wow. So it turns out that when these balloons go into this very cold liquid, what happens is the liquid nitrogen actually cools down the gas that is inside of those balloons. And it makes those gas molecules slow down and physically get closer together. And we can see that the latex balloon that is surrounding that pocket of air also gets a lot smaller. That's why they look so shriveled when they come out of the liquid nitrogen. But the moment that these things come back out into this nice warm room temperature air, you can almost see them going back to normal. So that means that none of these things popped in the liquid nitrogen. None of them broke in the liquid nitrogen. Instead, all we did was change the speed of those molecules. And again, as they come back out into this nice warm theater, those molecules are being heated up again. They are being almost re-energized so that they can start to move faster and get farther apart and almost re-inflate these balloons. All right, so we're down to our last 2. So we'll put these on the table together. And Sue, I'm curious if any other questions have come in.
We had some questions from earlier from people who are really curious, including Brian and Abigail, that can we make this stuff at home and how do you make it?
Can we make it at home and how do you make it? That's a really good question. I also do have to say that one of these balloons actually did pop, unfortunately, so we're just gonna throw that behind us and ignore it, because that one did not prove the science that I wanted it to. But all of our other balloons did go back to normal. So how do we make liquid nitrogen? The answer is by using a factory, essentially. We cannot find this stuff in nature. It is just too cold to exist on this planet. So that means that we need to make it ourselves. You can't do it at home because, for example, your freezer is not cold enough to freeze liquid nitrogen. So instead, we just need to have these big factories that essentially take nitrogen out of the air, because most of the air around us is made out of nitrogen. We don't use it in our bodies, so that's why we don't hear about it very often. We only hear about the oxygen and carbon dioxide in the air, but there is a ton of nitrogen. So these factories take that nitrogen, they lower the temperature of the nitrogen gas down to -321 degrees, and then that air, or I should say the gas, will condense and turn into a liquid. And then they collect that liquid and sell it to museums and universities so that people like us can actually teach people like you more about it and more about the experiments that you can do with liquid nitrogen. But that was a really cool question. Any others that you want to mention?
That, I think, is it so far.
Okay, very good. Well, there's one more small experiment that I would like to show you before we get to our final experiment. And for this experiment, we are going to pull out a flower, specifically a rose, because Valentine's Day did just happen. There are a lot of extra red roses at your local florist. And what I'm going to do, very simply, is pour liquid nitrogen over this flower and then hit it on the table. Now, it sounds like a simple experiment, but I'm curious to know what you think will happen to this rose. So while you're thinking about it and typing in your prediction, I'll tell you a little bit more about it. You can see that this is a real rose. I'm not trying to trick you here. It's actually probably hard to see. Let's do it like this. It's hard to see against my red coat. I'm sorry that I'm losing my voice too. But you can see that this is a real rose. It's kind of squishy. It feels soft, okay? You can see how much I'm squishing it back and forth. It's not breaking as I'm squeezing it as well. And it's essentially a solid. So we're going to find out what happens to solids when you super cool them. So the answer is like, can this turn into another state of matter, for example? Is there something beyond being a solid? So what do they think, Sue? Is there anything coming in?
A few people have said they predict that it's going to shatter.
Oh, okay. Wow. A regular rose that's really soft will possibly shatter.
Also get hard.
Or just get harder. That's a
Yeah.
good one too. So let's find out what actually happens. I'm going to pull out a handy dandy styrofoam container for this one. We'll place our rose right inside of it, and I'll very simply pour liquid nitrogen over our flower. Probably put a few scoops in there because I do want it to be pretty well covered. Plus, every single time I pour liquid nitrogen over this flower, I'm pouring it directly onto it, which is making it cool down. Let's flip it over, do the other side. One more scoop for good measure. All right, and let's see what happens. Let's get a nice close-up on our table. Perfect, thank you. And here's our rose. In 3, 2, 1. Wow. 3, 2, 1. I'm making a bigger mess than even I expected. Let's do a few more hits. Okay. So what we've done, I just demolished this flower, by the way. I've made these little teeny tiny crumbly pieces all over my table. You can see how they're falling everywhere, how they kind of flew everywhere as well. That's going to be quite a mess to clean up. I apologize, everyone. But we can see that there is no other state for that solid to turn into, but instead it does get much harder. And that's because those solid molecules that made up that rose actually physically got closer together because we slowed them down even more than before. And if they're closer together, they're going to make that object much, much harder, more brittle, more glass-like, and easier to break. So, awesome job predicting that experiment. Sue, any questions coming in?
Well, folks were all really good at predicting what was going to happen to that flower. They did have a few questions as we've gone along. Sophie was wondering isn't it dangerous to touch things like the balloons and such when they're still cold and you take them out of the liquid nitrogen?
Yeah, that's a great question. It is true that these balloons and other things that you put into the liquid nitrogen will get very cold themselves. But especially with balloons like this, which are made out of this kind of material, they don't actually hold on to that temperature for very long. So that's why I was able to take out some of these balloons with my fingers, because it wasn't as cold as if you put a piece of metal inside of here instead. So it definitely depends on the material that you are super cooling with the liquid nitrogen when it comes to things like this balloon or even these little pieces of rose petal, which are now all over the table. Even right after they're in the liquid nitrogen, they are not too dangerous to touch, simply because they're not holding on to that really low temperature.
Do you have time for one more question, Emily?
Yes, let's do it.
So we did have Margaret and Kip who wanted to know if refrigerators use liquid nitrogen to make ice cubes.
Oh my gosh, do refrigerators or freezers use liquid nitrogen to make ice cubes? That is a really amazing connection to make, but the answer is no, simply because your refrigerator or even your freezer isn't cold enough to actually take liquid nitrogen and keep it in its liquid form. So instead, our freezers and refrigerators use a different type of technology to actually keep them cold. In fact, I believe it's very similar to how we make liquid nitrogen, kind of how your refrigerator works at home. But yes, we do not use liquid nitrogen to make ice cubes at home. I could do that here if I had water, or if I had a small, amount of water and an ice cube tray. I could do that with the liquid nitrogen, but that's not how your home does it. Yeah, really good question. All right, so folks, let's move on to our last experiment. We have made a big mess out of our table, but I'm going to attempt to make an even bigger mess, because now we're going to set our sights on this tub of water. Now this is very simply warm water inside of this container, and I will add dish soap to it. Now it already has quite a bit of soap in it already, but we'll add a little bit more. Let's even do a little bit more. And the next thing that I'm going to do, you've probably already guessed it, is I'm going to pour liquid nitrogen into this warm, soapy water. And I want to know, what do you think will happen when I do that? Now keep in mind that the water is warm. So what do you think will happen when our cold liquid nitrogen touches that warm water? Also remember that there is soap inside of it. So what will the soap do to this experiment? Go ahead and type your answers to Sue, and she'll let me know what you're all thinking.
I'll look for those predictions. I think it's going to bubble up.
So maybe the water itself will bubble up. That's a good one.
Yeah.
We can just check it out too. Maybe a lot of our viewers are unsure. That's okay too.
Oh, evaporate, mushroom cloud, volcanic explosion, bubbles, nitrogen. It's like elephant's toothpaste. It's going to come out of the tube. Oh, they're coming fast and furious now. Turn into a fog. Oh, no clue. I like this honest person.
That's a good one. Honestly, those were all amazing. I hope every single one of those predictions happens. So let's actually see what does happen. My goggles are definitely going on for this. They have been going on for the liquid nitrogen because it is dangerous to get it in your eyes, but I also want it on for this experiment. But let's see what happens in 3, 2, 1. Ooh. So not quite an explosion, but certainly an eruption of bubbles. Let's get another scoop of liquid nitrogen in there. Oh my goodness. We can even see it bubbling over the side of its container. So what we're seeing with this experiment is that as soon as our liquid nitrogen touches that warm water, it starts to boil very quickly, in fact. And as it's boiling, it is turning into a gas. And that gas is escaping the liquid. But here's a big one. Because our water is full of soap, that means that the gas is getting trapped inside of that soap, and these huge bubbles are erupting out of this experiment. And even every single time these bubbles pop, you can see a puff of smoke, not smoke, a puff of fog that comes out of that bubble. So you can actually see what is filling up the bubbles in this experiment. Let's do, how about one final scoop? And then, Sue, if there are any questions, maybe we can take one final question, and then we'll wrap it up for the day.
I don't think we have a lot of questions, but I do have a lot of exclamations. So how about if I just share some of those with you?
Yes, please do.
One word explosion. It's alive. It happened. It's amazing.
So cool. I'm glad you all liked it. I always love doing this experiment myself, too. Let's get another one in there. Whee!
You're going to be cleaning for a while, Emily.
I know, right? This is the cleanest mess you could ever make. All right. Well,
All right.
Sue, if there are no other questions, then I think we can wrap it up.
All right. Well, thank you, Emily. Okay, scientists, I hate to say it because we have so many good observations and probably a few questions we didn't get to in the Q&A. But it is really time to wrap up our Supercold Science presentation. And I'd like to thank you all for tuning in. We'd love for you to continue to follow us on social media, as well as check out our website, mos.org/mos@home for more great online science programming. And if you enjoyed today's presentation, please consider supporting our programming by visiting engage.mos.org/welcome. Thanks again. Keep thinking like scientists. Enjoy the rest of your day, and we'll see you soon.